Okay, welcome to my emath assignment video. So I'll start with a quick introduction. So we are given the value that b is equivalent to 3 and c is equivalent to 5. So we are supposed to sub these two values into question 1 where y equals x squared plus bx plus c. So the values are here, and using these values I'm supposed to make a graph as shown here. Now, as of now, the numerical discriminant is negative 11, and I use the formula b squared minus 4ac over here. That's how I get my numerical discriminant. And as of now, the values of x and 1 are not shown, but let's say I change the value to, let's say, 5 of one of my inputs. The value would thus change, and now the values of x1 and x2 are this and this, corrected to 3 dp or 3 decimal places, and I use the formula negative b plus minus square root of 4ac, b squared minus 4ac over 2a. Question 4. So how b and c affects the graph? So b is technically your line of symmetry, which is like the middle line of your graph. So the symmetry of the graph will shift to the left when b is greater to 0 and shift to the right when b is less than 0. So let's say b is 0. As you can see here, if I change the value to a positive number, so let's say 6, it will shift to the left here. Or let's say I want it to be a negative number, or negative 6, it will shift to the right over here. As for the value of c, now c is where your graph cuts the y-axis. So as of now, c is at 5. Let's say I want to change the value of c to 0 first. C will cut, your graph will cut when y equals 0. So when c changes, the graph will shift upwards when c is greater to 0 and shifts downwards when c is less or equivalent to 0. So let's say c is 9, the graph would cut at y equals 9, and if it's a negative number, it will shift downwards to negative 9 here. So as of the final question, how does the discriminant value changes the graph? When the discriminant is greater than 0, as you can see here, there are two real solutions. So as of now, there is one solution here where the graph cuts the x-axis, and one further down where you can't see. So however, if let's say I change the value to a smaller number like 5 and 5 again, so the graph will cut 2 points on your x-axis, as you can see here, and that is only for when discriminant is greater than 0. However, if let's say discriminant is equivalent to 0, there should only be one real solution, as you can see here, as only one point cuts through the x-axis, and thus only one solution. However, when discriminant is less than 0, there is no real solution, as no part of the curve or the graph will cut through the x-axis, and the imaginary number is used. So that is all for me for my emath assignment. Thank you for watching.